Alright, continuing with converting polar and rectangular stuff, we're going to branch from converting coordinates to converting entire equations. We're still going to use those same 5 basic conversion formulas, with these 3 at the top being used most frequently. Those are the most common ones. Does not mean you will not use the others. My writing is crap. Most commonly used, that's supposed to be an S. Still supposed to be an S. There we go. All right, the most commonly used 3 are those top 3. The bottom ones will be used on occasion. But we're going to use those formulas. And the easier ones are to go from rectangular equations to polar equations, where you have the x and the y, and you want to convert the x and the y to r and theta. Now remember, a polar equation is going to be in the form r equals, and then your equation is in terms of theta. If you think back to the polar graphs we've done like rose graphs, which was like r equals 2 sine of 3 theta, where it was r equals stuff in terms of theta. The limacons were things like 2 minus 3 cosine theta, where you had r equals something in terms of theta. That's what we're going to shoot for when we're converting. We want to get rid of x's and y's and be left with r's and thetas. And problem like number 1 is probably the easiest one. Because when I look at number 1, I see x squared plus y squared, and that's pretty nice because x squared plus y squared is in our formulas down here. So x squared plus y squared does equal r squared. So I'm going to turn x squared plus y squared into r squared. They are equal to each other. So r squared equals 9. And then I'm going to do the difficult task of taking the square root of both sides. And I know that r is equal to 3. So there is the polar form of the equation. There's no theta in this one, but that's going to happen sometimes. Hopefully you recognized x squared plus y squared as a circle. We've done circles before. This is a circle with radius 3. You take square root of that number, and in polar form, r equals 3 is a circle with radius 3. Number 2, x equals 5. This one's going to be a little bit tougher, but not a whole lot. I see x, and down here I see that x is equal to r cosine theta. So I'm simply going to take out the x, and in its place put r cosine theta equals 5. I'm not going to change the right side. Then to solve for r, I will simply divide both sides by cosine. Divided by cosine theta. That gives me 5 over cosine theta, which I'm okay if you stop there. But if this were a multiple choice question, I might have it written a little bit differently. Hopefully you remember that cosine and secant are reciprocals, so I could pull that cosine to the top and say that r equals 5 secant theta, because 1 over cosine does equal secant. We'll just leave the 5 up there with it. Okay, let's look at some of these, getting a little bit more difficult. Y equals 2x plus 1. I'm going to do the same type thing I just did. I know that y, that was definitely supposed to be dotted. Y is equal to r sine theta, so I'll take out my y and put in r sine theta equals 2x, but I don't want x's. I want to turn this into polar, so I'm going to take out the x, and I'm going to plug in r cosine theta. Is plus 1. And there I've got it into polar variables. I have r's and thetas. Now I want to try to solve for r, and this is where the problems get a little bit more difficult. These last 2 problems, solving for r wasn't any trouble. Just had to take the square root of the first one. This one I simply had to divide by cosine. Here, I've got r's in 2 different places. I have an r right here and an r right here. So if I want to solve for r, you want to get them on the same side of the equation. I'm going to do that by taking this whole term, 2r cosine theta, and I'm going to subtract it from both sides of the equation. And so that would give me r sine theta minus 2r cosine theta. And over here they cancel, leave me with just 1. And then looking over here, I see that my 2 terms, I have r sine theta and 2r cosine theta. I can factor the r out. They have an r in common. So I'm going to pull that r out, leaving me with sine theta minus 2 cosine theta. and then we'll finish solving for r by dividing by that. So we'll divide both sides by sine theta minus 2 cosine theta. And there is the polar form of the equation. That's where it starts to get tricky. Pretty easy the first step, because the first step you simply take out the x and the y and you plug in r sine and r cosine. However, sometimes the solving for r after that gets a little bit tricky. Number 4, we have y equals x squared, and I'm looking over here. Y is r sine theta, so I'm going to do the same thing. I'm going to take out the y. Let's make that red, stay with my color coding here. I'm going to take out the y, and I'll plug in r sine theta. I'm going to take out the x, and I'm going to plug in r cosine theta. So we get r sine theta is equal to r cosine theta all squared. So let me square that right side. R sine theta, that would be r squared cosine squared theta. You just square each one of them. And now the trick is how I'm going to get r by itself. This one's a little bit trickier because now I have one r here and I have two r's right here. So the challenge in simplifying this, let's see how to explain this. Who knows? I'm tempted to subtract one of them over, but since my r's are a little bit different, what I see here is if I divide both sides by 1r, if I divide both sides by 1r, over here my r's cancel, and right here r goes one, this r is going to cancel one of those, leaving me with sine theta equals r cosine squared theta. Now to finish solving for r is pretty easy to see, I hope. It's r times cosine squared, so we will divide by cosine squared theta. Divide by cosine squared theta. Over here the cosine squareds cancel, and you get sine theta over cosine squared theta is equal to r. And I'm happy if you can get that far. We'll stop there. You could clean that up and put it in terms of like tangent and secant or something like that, but I'm not going to worry about that. So there we go. There is converting from rectangular to polar. Honestly, I think these are the easier ones, going from x's and y's to r's and thetas. Going the other direction, going from polar into a rectangular, well, remember rectangular is our old-fashioned y equals some function of x. So we're going to try to solve and get this to be y equals something in terms of x, if possible. And let's see what we can do here. Number 5, we have r equals 8. R equals 8. Let's see what I can do. R equals 8. Well, in the back of my mind, I know that this is a circle. It's a circle with radius 8. And so that's just something I'm thinking about in the back of my mind. And so I know I'm probably going to need to steer towards the equation of a circle, which is x squared plus y squared equals r squared. The way I'm going to get there to get the full circle is there's two ways. I'm going to do this. I know that r is equal to the square root of x squared plus y squared. So I'm going to take out my r, and I'll plug in the square root of x squared plus y squared equals 8. And then I will square both sides of the equation. Square both sides of the equation, which will give me x squared plus y squared equals 64. And that is the equation of a circle with radius 8, centered at the origin, and you take the square root of that number to get the radius. The other option is you could have squared from the very beginning. Instead of plugging in the square root of x squared plus y squared, you could have started by squaring both sides of the equation, which would have given you r squared equals 8 squared, or 64, and then you could have plugged in x squared plus y squared for the r squared, which would have taken you to the final answer. Either one is about the same. I don't think one is necessarily more difficult or easy than the other. Let's see, number 6, r equals 2 cosine theta. Now here is where The polar ones get a little bit difficult because you may be looking at this and thinking, oh, well, I see the r. I know that r equals the square root of x squared plus y squared. So you want to do this. R equals the square root of x squared plus y squared. But then we run into a problem because here I have 2 cosine theta on the right side, and I see a cosine right here. I see the cosine part, but the problem is I have a 2 in front of this cosine, not an r. We need an r. So there's not much I can do with just 2 cosine theta. So what we're going to do, instead of plugging in for r at the beginning like that, I'm going to try to force this to have an r cosine theta. I really want an r with that cosine, because if I have the r, then I can plug x in its place. Well, the way I'm going to get that to have an r is I'm simply going to multiply the right side of the equation by r. But if I multiply the right side, I have to multiply the left side. That'll give you r squared equals, and 2 cosine theta times r is the same thing as 2r cosine theta. And now I can take out r cosine theta, and I can plug x in its place. There you go. So out comes r cosine theta, in goes the x. The 2 is fine, it's not going anywhere. And r squared is equal to x squared plus y squared. So I'll take out the r squared. X squared plus y squared equals 2x. And honestly, if you can do that, I'll be happy. We'll just stop right there. Once you get all of the r's and thetas out and get it in terms of x's and y's, I'm happy. So there we go. And I think there were 2 more problems I wanted to do. Tangent theta equals 6. Tangent theta equals 6. This one's not going to be bad at all because tangent actually shows up in those formulas right here. Tangent theta is equal to y over x. So I'll simply take out the tangent, put in y over x. That equals 6. And then I'll finish by solving for y. If I can solve for y, I will. So I'm going to solve for y by multiplying both sides by x. And you get the line y equals 6x. Good, good. Good, 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 good. And remember the last one, theta equals pi over 3. Theta equals pi over 3. Well, there's nothing that really has theta by itself. We have a whole bunch of things. Well, I've got r cosine theta, I have r sine theta. I have this tangent theta equals y over x. This one on bottom is kind of the cleanest of the things that have a tangent, or things that have a theta. The reason I don't want to use these first 3 is because these all have an r, and there is no r in this equation. So I'm going to see what I can do with tangent theta. And the way I get tangent theta here is you can actually take the tangent of both sides of an equation. So if I have theta equals pi over 6, I put a space there because I'm about to put tangent in front of them. I'm going to take the tangent of theta, and I'm going to take the tangent of pi over 6. Well, tangent theta, we're just going to leave as tangent theta for now. But tangent pi over 6, I can do that. That's on the unit circle. Pi over 6 is right here. How did I say pi over 6? That's pi over 3. Okay, forget pi over 6. Pi over 3 is up here. And the coordinates of pi over 3 are 1/2 and root 3 over 2. If you remember your tangent, it's sine divided by cosine. If I do root 3 divided by 2 over 1/2, you would flip and multiply, and that turns into simply the square root of 3. And I know that tangent theta is equal to y over x. So kind of the same thing we did on that last problem. And then finally, we will multiply both sides by x to solve for the y. So our equation ends up being y equals the square root of 3 times x. There we go. So that is converting polar equations into rectangular equations. And we started by converting rectangular equations into polar equations right here.